For centuries, humanity has gazed up at the stars, wondering, are we alone in the universe? From ancient civilizations that mapped the heavens to the groundbreaking space missions of today, this question has captivated our curiosity, inspiring us to explore the unknown. Now, a recent discovery from NASA's James Webb Space Telescope, JWST, has reignited that age-old question in a way we've never seen before. Mysterious lights resembling those of Earth's cityscapes have been detected on a planet orbiting Proxima Centauri, the closest star system to our own. This exoplanet, known as Proxima Centauri b, has long been a subject of intense study due to its location in its star's habitable zone. But what the James Webb Space Telescope has found has left scientists baffled and exhilarated. Approximately 4.24 light-years from Earth, Proxima Centauri b is the closest known exoplanet and has been a prime target for astronomers hunting for habitable worlds. But these recent findings go beyond just the potential for life. They suggest the possibility of an advanced civilization. Could these strange lights be a sign of intelligent life? Or is there another explanation? The detection of these city-like lights is no ordinary observation. The JWST's incredible infrared sensitivity allowed it to peer into the dark side of Proxima Centauri b, where these lights were observed. The precision and depth of the telescope's capabilities have allowed it to pick up on faint emissions that other telescopes might miss, and what it found could change our understanding of the universe. To grasp the magnitude of this discovery, let's break down what the James Webb Space Telescope actually does. Unlike traditional telescopes, which rely mostly on visible light, the JWST primarily observes infrared wavelengths. This means it can detect heat signatures and penetrate through dust clouds that would otherwise obscure our view. And in the case of Proxima Centauri b, this ability was crucial. The telescope didn't just observe reflections of starlight. It picked up on patterns of light that seemed to be self-generated, much like the glow of city lights on Earth. But before we jump to conclusions about alien civilizations, it's important to ask, what else could these lights be? Scientists are carefully examining all possibilities. Natural sources of light, such as volcanic activity, lightning, or even bioluminescent organisms, could account for some of the emissions. However, the consistency, intensity, and the repeating patterns of these lights don't fully align with these natural explanations. Instead, they bear striking similarities to artificial lighting, the kind we use to illuminate our cities at night. The possibility of alien life has long been a subject of speculation, but this discovery pushes us closer than ever to the edge of what we know. For years, scientists have debated how we might first detect intelligent extraterrestrial civilizations. Some have suggested that we might pick up radio signals, while others have proposed we could detect industrial pollution, such as chlorofluorocarbons, CFCs, in the atmosphere of an exoplanet. But this is the first time that something as striking as potential city lights has been observed. To better understand these lights, scientists are now focusing on Proxima Centauri b's atmosphere. Could this planet, orbiting a red dwarf star, actually support life as we know it? And if so, could it sustain the kind of life capable of building cities? We know that for a planet to be habitable, certain criteria need to be met. The presence of liquid water is a key factor, which is why Proxima Centauri b has always been an intriguing candidate. It lies in its star's habitable zone, where temperatures could allow for liquid water on its surface. But there's more to habitability than just the right temperature. A planet's atmosphere plays a critical role in whether life can thrive. The James Webb Space Telescope, with its ability to analyze the light passing through a planet's atmosphere, is equipped to look for specific chemicals that could indicate life. Gases like oxygen, methane, and water vapor are all considered potential biosignatures, the kinds of compounds that living organisms produce. But JWST can go a step further, examining not only whether these elements are present, but also in what quantities and ratios. This could provide key clues about whether Proxima Centauri b is indeed home to life. What makes this even more intriguing is the infrared signature of Proxima Centauri b. Unlike many other rocky planets, it has a thermal profile that doesn't perfectly match its host star. In other words, its temperature patterns are unusual. This raises questions about what's happening on its surface and in its atmosphere. Could these anomalies be explained by something as simple as unusual weather patterns? Or is there a more complex explanation involving technology, infrastructure, or even energy production? The possibility of an atmosphere on Proxima Centauri b also raises the question of day and night cycles. Like Earth, this exoplanet experiences periods of daylight and darkness, which significantly affect its surface temperature. If the planet lacks an atmosphere, the temperature difference between day and night would be extreme, leading to a harsh, inhospitable environment. But if Proxima Centauri b has a robust atmosphere, it could help regulate these fluctuations, making the planet more suitable for life, and perhaps even civilization. While the lights observed by the JWST are a tantalizing hint, much more research is needed before any definitive conclusions can be made. In the meantime, scientists are using both the James Webb Space Telescope and other ground-based telescopes to conduct follow-up observations. By analyzing the light spectrum of the emissions from Proxima Centauri b, they hope to identify specific compounds in its atmosphere. This analysis will help determine whether the lights are natural or artificial, and what they reveal about the planet's potential to support life. One of the biggest challenges in this investigation is distinguishing between geological and biological sources of the observed gases and light patterns. Volcanic activity, for example, can release large amounts of carbon dioxide and sulfur compounds, which might mimic the atmospheric conditions of a life-bearing planet. But if the lights are truly artificial, created by a civilization, we might expect to see other signatures, such as industrial pollutants or energy emissions, that would indicate the presence of advanced technology. So, how do we proceed from here? Future missions are already being planned to continue the search for life beyond our solar system. While the James Webb Space Telescope is an incredibly powerful tool, it is just the beginning. Ground-based observatories like the upcoming Extremely Large Telescope, ELT, which is set to begin operations in 2028, will complement the JWST's discoveries by providing even more detailed observations of distant exoplanets. With a mere 39 meters in diameter, the ELT will have unprecedented resolving power, allowing astronomers to directly observe exoplanetary atmospheres in greater detail than ever before. These upcoming telescopes will also employ new techniques to block out the light from a planet's host star, making it easier to see the faint light reflected off the planet's surface. This technique, known as coronagraphy, will help astronomers better understand the atmospheric conditions of planets like Proxima Centauri b and potentially identify artificial light sources with even greater accuracy. But the search for life beyond Earth is not just limited to telescopes. Concepts like the Breakthrough Starshot initiative propose sending small, light-propelled spacecraft to the Alpha Centauri system. While these missions are still theoretical, they represent a bold new vision for exploring nearby stars and exoplanets. If successful, these tiny probes could provide direct, up-close images and data from Proxima Centauri b, potentially confirming whether an advanced civilization exists just a few light-years away. As we continue to push the boundaries of our understanding, the discovery of the mysterious lights on Proxima Centauri b marks an exciting milestone. Whether these lights turn out to be artificial or natural, they remind us that the universe is full of surprises and that the search for extraterrestrial life is far from over. Each new discovery, each new piece of data, brings us closer to answering the ultimate question: are we alone? While we may not have definitive proof just yet, the James Webb Space Telescope has given us an incredible glimpse into the possibilities that lie beyond our solar system. As the scientific community continues to analyze the data and refine our techniques for observing distant exoplanets, we remain hopeful that one day soon, we will uncover the evidence we've been seeking for so long. The journey to understanding Proxima Centauri b and the lights observed on its surface is only just beginning. With each new observation, we gain a clearer picture of this distant world and its potential to harbor life. As technology advances and our telescopes become more powerful, the answers to our biggest questions may finally be within reach. Whether we find an alien civilization or simply a unique natural phenomenon, one thing is certain: the universe is far more mysterious and wondrous than we ever imagined. And as long as the stars continue to shine, humanity's curiosity will keep driving us to explore, discover, and search for life beyond the limits of our planet.